start recording.
Yeah. Okay, so today, this is the agenda. We'll do a warm-up on Pear Deck using about lines and functions, just pretty much stuff that we have covered up till now. Not a very long, lengthy thing, but definitely worth looking at. It. The test has been written, and so I'm trying to kind of just give you some ideas of what will be seeing on that test. Then we'll cover the new material, and again, that's not very lengthy. So reminders, the test, of course, is on Thursday during class time. Make sure you figured out how to use the lockdown browser. Some of y'all had not, and I know it wasn't all your fault either, but just before class that day, I would definitely go in and make sure you know how to do that. There is a review under homework worksheets on Blackboard. It would be a good idea to have looked at that before you come to class tomorrow, so you can kind of highlight things that you might want to go over in more detail. And then tomorrow we'll take questions and review for the test. So today is the last new material that we'll be covering. And I will put, are we recording? Because I paused it earlier. Yeah, okay. I will put this slideshow will be up on Blackboard, so you can see it if you want. These are the forms of equations of lines that you should know: point slope form, slope intercept form, standard form we've kind of talked about, and how to find intercepts. These are all just different ways of knowing how to write a line. And again, I'll put this up. It will be up on Blackboard if you want to look at it in more detail. Then these are the special types of lines: horizontal, vertical lines, parallel lines, and perpendicular lines. So you should know the details on those types of lines. Here's the first question. What is the domain and range of this function? And did I know? Oh, you know what? I don't think I am. Yeah, I am. Okay, let's see here. Now, I did, for some reason, I don't have responses on this. So I don't know why I did not put responses. So would someone tell me what the domain and the range function is?
Wouldn't it be negative infinity to positive infinity?
That's the domain, negative infinity to positive infinity. And what's the range?
Negative infinity to 1.
That's right. Good, great. So here's the first question that actually has some choices that I can look at your responses. Write the equation of the line that is perpendicular to x equals 5 and passes through point 10,4. And really, if you understand the concept of horizontal and vertical lines, this should be a really quick answer. Okay, so most of y'all are getting this right, and some of you are picking the distractors that I purposely picked because I knew that they would be good distractors. So if you think about what the line x equals 5 looks like, it is a vertical line that passes through 5. And so the perpendicular to that would need to be a horizontal line that would pass through the point 10, 4. And so the equation that would go with that would be y equals 2, 4. Remember, the slope of a vertical line, it's no slope or undefined slope. And so the slope of a horizontal line is 0 slope. Does that make sense? Are there any, can I clarify that any further?
Yeah, I was gonna say most of them aren't really gonna look like this. This is like just because we have a kind of weird special case of undefined slope, and also there's a lot of mowing, so I'm probably like leaning in trying to hear what's happening.
Okay. All right, then let's go on to the next one. Find the equation of the line that passes through the point -2, 5 and is perpendicular to 2x plus 5y equals 10. That answers all over the place here. Okay, so first of all, we want to find the slope. Someone tell me how to find the slope.
2x plus 5y equals 10. You gotta solve for y.
Solve for y. Okay,
The equation should, the equation I got is y equals -2/5 plus 2.
perfect. Okay, so what's the slope of the original line?
the original, the
Mhm.
negative 2 over 5, but if we're going to check for perpendicular, we're going to plug it. Well, first we're going to flip negative 2 over 5x, and you should
Uh-huh.
give,
What's
I
the
have,
slope of perpendicular?
I made it positive, 5 over 2.
Perfect. So make sure
And then-
that you do that. Good, good. Who is this talking?
Timothy?
Timothy, great. So that's the thing that people forget to do is a perpendicular. So you find the slope of the original line, then you throw out that original line. You don't need it anymore because you found the slope, and then you take the opposite and flip it. Okay, then tell me, Timothy, then what did you do from there?
Then you're going to use slope intercept.
Okay,
Yeah, sorry, point slope for,
point slope. Okay, so
and
tell
then you
me.
already have, okay, so should be y minus 5 equals 5 over 2, parentheses x minus 2, and
Mhm.
then you distribute, and you should come out to 5 over 2 times 2 equals 5. I'm sorry, not equals 5, my bad, minus 5. And then you add the 5 to both sides, and you should come out to 5 equals 5 over 2.
So this should be plus 2. I think you said that. And
Sorry?
then yeah,
Yeah,
yeah, sorry about that. Yeah, because minus and negative is going to make it a positive 2. I believe you told me that. Yes, great. So that's the thing, is make sure that you read the problem carefully. If it says perpendicular, find the slope of the original line, then just throw out the original line. You don't need it anymore. And then flip it, take the opposite of it, and go from there. And watch your signs. Okay. Okay, the next one. Okay, explain which graph represents a function. Y'all are all getting it so far. Yay. Okay, so on this one, this A does pass the vertical line test, B does not pass the vertical line test. Here, every Y, I said every Y is paired with exactly one X, but that's not true, because if you pick, like, just pick any 2 points here, this is the point 3, 3, this is the point negative 3, 3. So you can tell that the Y value, 3, is paired with both a 3 and a negative 3. So that's not true. The definition of a function is that every X is paired with exactly one Y. Okay, so the Y values can be paired with more than one X, but the X values cannot be paired with more than one Y. Find f of negative 2. Good. Y'all got this one.
Did we throw anything at them that was undefined so far? I can't remember doing that.
If f of, you mean an undefined, if I said like f of something that's undefined?
Yeah.
I don't think we have. Yeah. So yeah, and we may want to talk about that. So the points that this is, if you wanted to write these as ordered pairs, this would be -2, 0. This would be -2, -2. This would be -2, 4. Oh, and I put that as one of my options. Probably we're not going to have that, but I just needed a fourth option. -2, f of -2 is undefined. That would mean that there's no place on the graph where f of -2 would happen.
Yeah, so
Yeah.
if we do like a square root function, we could get things that are undefined, maybe.
Yeah, it could happen, but yeah, probably not going to give you that on this test. But so if we look at -2, 0, -2, 0 is right here. So that's obviously not. -2, -2 is right here, not on the line, nope. -2, 4 is right there, so that's the one right there. And all of y'all got that answered, so that's awesome. Use the graph to find everywhere f of x equals to 2. It was several different answers. People are answering differently on this one, but most of y'all are getting it. So when they say use the graph to find everywhere f of x equals 2, really what they're doing is saying when does the y value equal 2? So if I say when x equals 3, so I will go over 3, 2. Nope. When x equals -2, -2, 2. Nope. When x equals -4, -4, 2. Yep, that one works. And then also when x equals -0.75, that'd be right there approximately. So that one would work too. So it would be D, because you can have it happen more than once. If you think about that, that definitely still fits the definition of a function, because this x value is paired with exactly 1y, and this is paired with exactly 1y. So it's still fine. The y values can repeat all day long. It's the X values that we're concerned about.
It's like a Coke machine with 2 Coke buttons. It's okay.
That's right. All right. I mainly put this one on here because of the negatives. I want to see if what's going to trick some of you up is the negatives. Yay. So far, so good. Y'all are all getting this right. Makes me happy. Oops. Too soon. Okay, so there's many ways to approach this. I'm just going to go ahead and take that -5 and stick it in there for that x. And that'd give me -7 minus 3 times -5 plus 4, which would be -7 minus 3 times -1, which would be -7 plus 3, which is -4. And y'all could have done that differently for sure. But hopefully everyone sees, if you missed it, you see why you missed it. Probably there was a sign somewhere that you didn't do correctly. So watch those signs. Don't y'all love how I name people? Maura Bacon is going to a park where C is equal to 18 plus 2.75 R, models the relation between the cost in $C and the number of rides she goes on R. Interpret the slope and the y-intercept of the problem. You'll probably be asked to graph something like this as well. So make sure that you can graph and use the correct units and scale and label your axes.
Miss Watson, it
Yeah.
hasn't on with my school email, so I was just making sure you can see me on there.
Oh, good. Thank you. Yeah, perfect. That's Aurora, right? Kind of all over the place here. Okay, let's go ahead and talk about this one. So if you think about this, everyone who is entering the park, more than likely, if they're an adult or whatever, is going to be paying the same thing to get into the park. So looking at this equation, C equals 18 plus 275R, what do you think is the entrance cost to the park? How much does it cost just to walk in the door?
$18.
Yeah, $18, right? So that doesn't change for anyone, right? That just to walk in the door, that stays the same. If you decide you don't want to spend very much money, you just want to go to the park, then you pay $18 and you just walk around in the park. But if you want to ride all the rides, every time you ride a ride, it's going to cost you $2.75. I really don't know any parks that work like this, but it's anyway. So what's changing is, what's causing the change is the rides, right? So the 18 is a constant. That means that's where you start. That's your y-intercept. Then the 275 is what makes the trip to the park more expensive, because every time you ride a ride, you're going to be adding 275 to your fun at the park. So the slope is what's changing, and it's always going to be, when it's in this form, the slope is always going to be the number in front of the variable. The slope is 275, and it's the cost in dollars per ride. And then the y-intercept is going to be a number that doesn't have a variable attached to it, and that doesn't change. That's going to be a constant that won't change for anybody or anything in the problem. So the y-intercept would be the 18, which is how much it costs to enter the park before you go on any rides. So what I would recommend on these is always just think, what does this actually mean? What is this telling us? If they say the cost of operating a company is $2,500 a day plus $9 for everything manufactured, the $2,500 is the constant that it costs the company per day. The cost to manufacture things is what causes things to change, because the more you manufacture, the more it's going to cost to operate your company. So always think about what it means. Okay, now we're going to start working on the book work. This is one of those slides where you can just answer yes or no. But I would like to see everybody answer here, whether you're ready to go on. And again, some people are saying no. No, because, yeah, are there any questions before we begin? And I see some yeses. And so if you have a question, this would be a great time to ask it. And if it's not something specific, then you let us know. Yeah, I see people changing their minds, but I'm happy to answer questions now. And if you're not really sure what the question is, you're just confused about something, then I would recommend looking back through the problems and seeing like what it is that's causing confusion. And then tomorrow, or even after class today, we can address that. So I just want you to think about that. Does anyone have a question they want to ask right now to get clarified right now? Okay, let's keep going then. Okay, this is the first problem in our set of problems. The distance d in miles that a train is from a station after X hours is given by the formula d of X equals 150 minus 20X. Okay, so before we do anything with this problem, let's talk about what this means. So we got a train and it is approaching a station. And this is the distance, d, between the train and the station. So what does the distance start out as? What does that d start out as?
150 miles.
Yes, thank you. So this is where it starts. That's how far it is at first. Then, and you'll forgive my art, it's getting closer and closer, right? So what's happening to the distance is it's decreasing, right? This distance, as the train moves forward, the distance to the station gets less and less. By how much? Or I'm sorry, yeah, by how much?
20 miles per hour.
Right, right. So it's getting closer and closer by 20 miles per hour. So this is what's changing. So calculate d of 5 and interpret the results. So we'd say d of 5 equals to 150 minus 20 times 5, which would be 150 minus 100, which is 50. So what does that mean? What is this number? The 5.
Hours.
Oops, you know what? I'm not showing. I think I'm showing stuff to y'all and I'm not. Sorry. Whoops, I've lost my. Okay, here we go. Sorry about that. I'm drawing and talking and not. So this is what's happening. The train is approaching the station, getting closer and closer. So they're asking you calculate d of 5 and interpret the results. So 5 is the X, which is our hours, right? And D, this 50, what is that?
The remaining distance.
That's right. So when you're asked to interpret, you'd say after 5 hours, or you can say it in your own words, but you do need to, the context, you can't just say 550. After 5 hours, the train is 50 miles from the station. All right, so what is the slope of this? This is just exactly like what we just did, except for the only difference in this problem and the one we did right here is that before we were just like using y equals mx plus b, and now instead of saying y equals, we're using function notation. So what is the slope of this graph?
20.
What?
20
What kind of 20?
miles per hour.
Okay, but the slope would be not 20, but
20 over 1.
okay, but what's
Negative 20.
Negative 20, right? Because the distance is decreasing, right? So if you think about this line, this is the distance from the train station is going down. So the negative is important. So the slope is negative 20. And what does that represent? that represents miles, right?
So the units on the slope should be miles per hour.
Yeah. Well, yeah, but
Oh yeah. So you have for every hour. That's it.
yeah,
That's
yeah,
the
right,
same thing.
yeah.
Sorry.
No, yeah, right.
Didn't
We
read it all
have,
the way.
but it is super important that you put if you put negative 20 miles per hour, that's fine. Okay.
And I would say like in general, like if you just get your x, the number and the units on it, and you get your y and you get the number and units on that, and you get your slope and you get the number and units on that, like that's basically what you need to interpret these things. All the other words kind of fall into place just from reading the problem. But if you just get your like units and the number and on there, like after 5 hours, the train is 50 miles from the station. If you say 5 hours, 50 miles, like all the rest of the words, like they're gonna fill themselves in pretty much.
They will. So that's it. Find the slope. And then of course the y-intercept would be the 150 that the train started out away from the station. Okay, so the next 4 problems deal with linear and nonlinear, and hopefully you watched the video and got a very clear concept of this. But let's just look really quickly at some examples of linear functions. So this first one, f of x equals 3x plus 4. So what's the y-intercept there?
4.
Yep. And the slope is
3x.
3. Remember, the slope does not include the x. It's just the number in front of, right. And which way is the graph going? Is it increasing from left to right or decreasing from left to right?
It's increasing.
Right. So it's going to look something like that, right?
Mm-hmm.
And then this one, negative 1/2 x minus 1.3. Same thing. It's y equals mx plus b. Which direction is this one going from left to right?
Direction, or is it increasing or decreasing?
I'm sorry, increasing or decreasing. Thank you.
Oh, you're good. Decreasing.
Decreasing because the slope is negative, right? Okay, and then this one, h of x equals 3. Increasing, decreasing.
Say it's staying where it's
Flat.
Right, and that's called constant, okay?
right.
Constant. Now, let me ask you this question. Let's say we had x equals to some number, 5. What does that line look like?
Vertical.
It's a vertical line. Is it a function?
As long as that doesn't repeat, then.
Okay, but in this case, what are all the x values?
It's not a function.
It's not a function, right? So there's no way that you can express that in function notation. Okay, so you're never going to see this. All right, because it's not a function. All right, so this is r of x equals negative x over 3. Now, sometimes you'll see this, and this confuses people. What's the slope of that line?
Negative 1 over 3.
Negative 1 over 3, right. That's the same thing as saying negative 1/3 x. All right. So that is a linear function because we've got a slope of negative 1/3. And what's the y-intercept?
No, there is none. So it'd be
0.
0, exactly. All right, so that's fine.
And this is one of the
Undefined
scenarios
or no
where you
slope.
want to say 0, right? Like you don't want to say there is none, because if there is none, that means it doesn't cross the axis.
all right. As long as we got that straight.
Okay, now here you are going to be asked to be able to plot points on these and graph them, but all I really want to do right now is talk about what the general shape is. Does anyone remember the general shape of an absolute value function?
Yeah, it looks like a triangle or like a V.
Oh, like a V, right, like the V in value, okay? So that's what this is. And do you see why that is not linear? It doesn't have a constant rate of change, right? This line is positive slope, or this ray, and this ray is a negative slope. It's going down from left to right. So that is not a linear function, okay? Now these are all functions, but they're not linear functions, and that's what we're being asked in this lesson, to be able to designate between functions that are linear and functions that are not linear. Okay, so what does an x squared function look like?
Like a parabola.
Yes, that's right. It always looks like some kind of a U. Okay, again, that is not linear. Then here we go. Here we have another absolute value function, and again, it looks like a V. And there are many, many other nonlinear functions that we will be getting into later on. We'll talk about them. But for now, these are the absolute value function you should be able to recognize is a V. And these are called quadratic functions. And they always look like a U of some sort. All right. So coming down to this problem right here. Let's first of all, let's identify linear or nonlinear, and then we will sketch the graph. Okay, so what's this one?
It's a linear function,
It is linear.
but it's not constant.
It's not constant. Good, because what's the only time it's constant is when?
If it's like y equals or x equals.
It's only going to be a constant. It's only going to be a constant function is if there is no x in the problem. So and I know we don't have to do all of these, but why not? So this would be constant. And what other of these functions would be constant and linear?
34.
34, yes. So see, those don't have any x attached to them, right? So that's constant and linear. And that just means that they are going to be what kind of line? What kind of line would those be?
Horizontal line.
Yes, right. Okay. So 32 again is what kind of function? Is it linear? Number 32?
Yeah, it's linear.
Yeah. Is it constant?
No.
Nuh-uh. Nuh-uh. Because it's got that x in there. It's got a slope that's not 0. All right, so 35, is this linear?
No.
No. What does it look like?
A V shape because it's an absolute value.
That's right. And what about 36?
Also
it's
no.
not linear.
Not linear. It is also a V shape. And what about 37?
Also no.
Nuh-uh. What about 38, just for grins?
It's like an upside down check, sort of.
Okay, so what is that? Does anyone know what that function is called?
I forgot what the shape is called.
It's a
Square root of x.
square root function. Is a square? Do you think a square root function is linear?
No.
No. And square root function looks like half of a sideways parabola. Okay, so let's go back and make sure we can sketch these graphs. So 31, what's the y-intercept?
0, 5.
0, 5. And what's the slope? Yeah, the slope is 22/1. So we go Up 22, way off the page, and over 1. So this is going to be a real. See, 122 is the point it's going to do. All right, 33, f of x equals to 1. What does that look like?
Horizontal line at 1y or at 0, 1.
That's right, good. All right, so 35, we're going to plot points, and in the next section, you're going to learn how to graph these without having to plot points, but right now we're going to plot points. So we have x and absolute value of x plus 1 is our f of x, or our y. So I always pick 0, pick a couple negative numbers, and a couple of positive numbers. Okay, so this would be the absolute value of -2 plus 1, which is the absolute value of -1, which is just 1. This would be the absolute value of -1 plus 1, which is the absolute value of 0, which is 0. This would be the absolute value of 0 plus 1, which is the absolute value of 1, which is 1. This is the absolute value of 1 plus 1. Okay, so if we graph this, -2, 1, -1, 0, 0, 1. And we know it's a V shape. That's what's so helpful. So once we get the V, we can just draw it. And if you don't, sometimes, I mean, I don't think this is going to happen to you, but there are times, like let's say you didn't pick enough numbers to get the V shape, then go back and pick some more numbers, because you know this graph has to look like a V. Okay. So then the last one, number 37. We know it has to look like a U. Go ahead and do myself rolling. So again, I'm going to pick some negative numbers, some positive numbers, and 0. So if you take -2 and square it, you get 4, minus 1 is 3. -1 squared is 1. Minus 1 is 0. 0 squared is 0. Minus 1 is -1. 1 squared is 1. Minus 1 is 0. 2 squared is 4. Minus 1 is 3. So we've got -2, 1, 2, 3, -1, 0, 0, -1, 1, 0, and 2, 3. Now resist the urge to make a V shape. You know it looks like a U, so make it a U shape, okay? Don't make it pointy. Okay, so this one says decide if a line can pass through these points. So what do we know about lines? They have a constant what?
Rate of change.
Rate of change, right. And rate of change is just another word for slope and for a line, right? So rate of change. Okay, so this we kind of talked about a little bit earlier. But what you want to do is take I'm going to deal with the y's first, because remember slope is y2 minus y1 over x2 minus x1. And I'll just tell you, some people, when they're doing this, that because the x is on the top and the y is on the bottom of the chart, they want to put the x's on the top and the y's on the bottom of the equation. So don't do that, okay? So first of all, we're going to look at the difference in the y's. So you always start with one of the y's and subtract the y in front of it, okay? So I'm going to take 3 minus -1, which it would be what? 4, right? Okay. Then I have to keep going, because this, I have to get a 4 every time. Otherwise, I know for sure this is not going to be linear. So I'm going to take the 7 minus the 3, and that also equals 4. And then I'm going to take 11 minus the 7, and that also equals 4. And then I'm going to take the 15 minus the 11, and that also equals to 4. So far we're great. We're good. We're good. So the top here is a 4. That's the y2 minus y1 every single time. But now let's check and make sure that that's also true for the x's, okay? So I'm going to take 1 minus 0, which is 1, 2 minus 1, which is 1, 3 minus 2, and 4 minus 3. So the x2 minus x1 is 1. So our slope is 4. And this one is really nice. And I think probably most of the ones we give you will be semi-nice like this. What's the y-intercept of this line?
0, -1.
Yeah. So our b is 0, -1. So what is the equation of this line?
Y equals 4x minus 1.
Beautiful. Now they want us to write this in function notation. So
Sorry, f of
no,
x.
yeah, perfect. But I wrote the y, but yeah, f of x equals 4x minus 1. Yeah, same thing. Okay, so now let's do the same thing here. Let's take, remember the slope is y2 minus y1 over x2 minus x1. So first let's check the y's. -2 minus -5 is what?
Three.
Yeah, because that double negative turns into a positive. All right, then what is 1 minus -2?
It's also 3.
3. And then 4 minus 1.
3.
Also 3. And 7 minus 4.
3.
3. Okay, so we're good for the y's. The y's are 3. Now let's check the x's. What is -3 minus -5?
2.
2. And what is 1 minus -3?
4.
Mm-hmm. So stop right there, guys, right? Because what should these be also in order for this to be a constant slope? So here it's 2. So with these 2 points, the slope would be 3 over 2, right? But with these 2 points, what would the slope be? Three over
4.
4. So this is not linear. Okay, you have to have a constant rate of change. Okay, does that make sense? You have to check to make sure that the slope is the same between consecutive points or between any 2 points. All right, so then this is actually the very last concept we're covering. It deals with intervals of increase and decrease. Here's a couple of examples. Okay, so what I do when I look at these, anywhere there's an endpoint, I draw a vertical line, and anywhere there's a hump, I draw a vertical line. Okay, and so here is, then I name the x values between those. So like right here is from -2 to 0, right? Right there. And then between these 2 humps is 0 to 5. Does everyone see what I'm doing? And then from here to here would be 5 to what? Oops, I forgot. That is an endpoint. So it's 5 to 8, right? Because there's not an arrow. Okay, so now once I've done that, now I'd look and see, is it increasing or decreasing on those intervals? And just let me tell you guys, you don't, when you're talking about increasing and decreasing, just always use the open bracket. Don't use a closed bracket, because like right here, what's happening? Is that increasing, decreasing? What's it doing? We don't know. It's just there. So don't use closed brackets, okay? Always use open brackets. So what is happening between -2 and 0? Is that increasing or is that decreasing?
It's increasing.
Yes, it's going up from left to right. So this would be increasing. What is happening between 0 and 5? What's happening right there?
Decreasing.
Decreasing. Good. And finally, what is happening between 5 and 8?
Another increase.
Another increase, right? Now this is how I do it. And there's other ways you can do it, I'm sure. But this is, so decrease. So let's look at this one. Okay, so here on this next example, this goes off to infinity, negative infinity, right? Does everyone see that that's going to negative infinity on the x? If you're looking at it from the x perspective, and which is what we're always doing when we're talking about increasing and decreasing. It's like mile markers on the beach. It's like from mile marker 5 to mile marker 6, we're going up. From mile marker 6 to mile marker 7, you're going back down, whatever, but that's what's happening. So then what I do from there is, again, everywhere there's a hump or a defined endpoint, I'm going to draw a vertical line that crosses the x-axis. So there's a hump here, there's a hump here, there's an endpoint here. Okay, so what is happening from so our intervals are from negative infinity to -2, and then from -2 to 2, and then from 2 to 4. I'm just looking at what's happening on the x-axis. Now I go back and question myself as to what's happening on those intervals. So what's happening from negative infinity to -2? We are decreasing, right? And what is happening from -2 to 2, we are increasing. And what is happening from 2 to 4? We are okay. So on 65, now this one's kind of interesting. Does it have any humps? Like, does it have any maximums or minimums, which will be, does it have anything that looks like that or like that? It doesn't, right? So what is the interval here? Can anyone tell me what the interval is?
-infinity to +infinity.
That's exactly right. If you stretched this out like from, if you took it like it was a rubber band and stretched it horizontally, it would go from -infinity to +infinity. What is happening as far as increase or decrease the whole way? Is it increasing or is it decreasing?
Decreasing.
Yes. It's like the whole thing is going down the whole time, right? Okay. All right. So now let's look at this one. Someone tell me the intervals. What's the first interval?
-2, 1.
-2 to -1, right?
Yeah.
Okay, and what's the second one? Kelsey, did you answer that one before?
It's -1 to 0.
Yep. And what's the next one?
0, 1.
The next one?
1, 2.
Okay, so now let's talk about which one of those did I really not need? Can someone tell me which one of
Oh
these?
yeah,
I did it. I set it up, but what I'm saying is, which one did I not need to put a vertical line through?
the 0, 1.
Yes, this one right here. So I'm going to go ahead and erase it. This one, because can you see, it's not a dip. It's just there, right? So I really didn't need that vertical line. It just tricked me into putting it there. So really, this last one from 0 to 1 and 1 to 2, if you did that, it's no problem. But I'm going to go ahead and combine that and make it 0 to 2. So let's go back and look at what's happening on the intervals from -2 to -1. What's happening?
Increase.
And from -1 to 0, what's happening? Decrease. And from 0 to 2, what's happening?
Increase.
Yeah. And this is the last one. When is the energy consumption increasing?
I can't
19.
read all these. I mean, well, I guess if you look at the other years, I guess. I'm trying to look at the beginning here.
Yeah, look at it's going up by tens.
Okay, I got it. I got it.
Okay. So when is it increasing?
1960 to 1980.
Yep, 1960 to 1980. And when else?
$1990 to 2000.
Yep. Good.
It might be worth mentioning like that break, and that they typically should not do that when they're making graphs.
Oh, yeah.
The little break.
Yeah,
It
yeah,
skips from like 0 to 1960, right?
Yeah.
If you make a graph, you should make it all consistent. If it's going by
Yeah.
tens, it should go by tens all the way. So I know they're doing it here, and they're doing it, and they're doing it correctly.
Yeah.
Like most of the time, like, I don't know, students tend not to be very good. It tends to mess you up more than it helps you. I don't know.
Yeah. It messes me up more than it helps me usually.
So typically don't do those breaks. Like count by the same interval.
Yeah.
Just like they did their y-axis, right?
Mhm. Yeah, it's not that hard to do. I mean, anyway. Okay, so we are through. We finished in record time. And are there? I'll be hanging around for office hours, or I'll come back in for office hours if you are wanting to discuss anything with me. And I know there's at least one person that I need to talk to after class. So hang around if you will.
So right here, do we need to write the U between the two intervals?
You can do that. Yes, that's a good habit to get into for sure. Okay, so before tomorrow, finish the graded problems. It's real short, should take you like 5 minutes, and then I would recommend that you look over the review so that you can come to class ready to ask questions or whatever. And that's it. And y'all can sign out if you want. If you have no further questions, feel free to leave me.
Thank you.